Thanks for coming back to part 2. My relay has not arrived yet, but all of the new capacitors have, so I'm ready to start the recap. You might notice that the tops of all of the electrolytics are marked, so I do that for a reason. It doesn't really apply to a unit like this. It's more so to units that have a lot more capacitors, usually ones that are more closely spaced, as well as ones that are nearly identical in size. But I do this as a habit to remind myself which capacitors have and have not been replaced. It can be really easy to mix that up, especially when you're doing larger units with many more capacitors. But it's still just a habit of mine. I do it on almost any recap. I'm starting with the bulk caps, the 6800 microfarads at 50 volts. The new ones are direct replacements, but they are quite a bit larger in diameter. However, they do match the outline or the trace on the board perfectly, so they're going to fit just fine. The old ones had the glue on there. It wasn't difficult to get off, but I was curious. These don't seem large enough to me to warrant glue, but I'm not an expert. Maybe there's someone out there who's been in some sort of design role that can tell me what's the typical standard size, as in diameter and height of cap, where you start to consider using glue. We'll see if I can get some of that glue off. I got some of the glue off. I couldn't get all of it, but none of it is near any of the through holes, so I'm not concerned. One thing that almost tripped me up on this unit, it's happened to me in the past, is the electrolytic polarization label on the board. So most of the units I'm used to working on label the negative lead. However, this unit is labeling the positive lead. These are the positive leads. So it is critical to pay attention to the polarization or the orientation of the capacitor before you remove it, so you don't install it backwards. If you want to see what happens, go to one of my Tektronix repair videos. I can't remember which one, but you can see what happens when you put one in backwards. I'm done recapping the amp module. I'm just waiting on the relay to come in so I can install it and reinstall the amp module back into the unit. Previously I mentioned removing this PCB so I can clean the volume potentiometers, but there's no need. You get plenty of access on either side, so I'm just going to clean it while it's installed. That ought to do it. I blew this out with my air compressor and I got some of the dust out, but there's still a lot of cleaning to do. Baby wipes again. Alright, that's much cleaner now. Now I would never claim that cleaning that like that would improve the performance or the longevity of this unit, but I like to treat everything like it's my own. Everything was open, it's exposed, really easy to clean. It took 5 minutes, so that's just kind of the standard that I hold myself to. All right, while we're still waiting for the relay, I'm going to remove and recap the power supply section. Trying to get this power supply board out, I disconnected the few connectors that there are. I removed the board from the 4 standoffs, but these 2 wires right here are really tight. It's making it, I think, impossible to kind of turn it over to expose the underside, so I think I have to remove this front faceplate here and possibly remove or detach whatever these wires are attached to. I believe it's the front power LED. Yep, so just the 4 screws on the top, 4 on the bottom, and the front faceplate comes off. And indeed, the 2 wires do lead to the front power LED. I'm hoping I can remove it from the front faceplate and fish it through the chassis, but it might be glued in place. I hope not. After a little maneuvering, this is about as good as I can get it. So that's enough of an angle for me to remove and reinstall new capacitors. I finished recapping and reinstalling the power supply board. It looks pretty good. I have received the new relay that I ordered. The electrical specs match or exceed the original. So it's got a 12-volt coil. It can handle up to 250 volts AC. And it's got an actual higher current rating at 8 amps. The original was only at 5 amps. Now the pin layout is obviously different from the original. There's a large gap between the coil pins and the contact pins. And if we look at the amplifier board, we can see the outline for the original relays on the right. It's very close to a square in shape. Now where I thought I'd be able to use the new relay is on the left, the narrower outline. However, I did not measure, I assumed, based on the pin layout. So I tried reinstalling it, and the pin layout does not match the through-hole layout. So I cannot use that new relay that I ordered. I did measure the distance between these contacts, or between the pins on the board, and they're very odd based on all of the newer relays that I've seen, at least on DigiKey. I've looked at, I don't know, 10, 12 different styles. None of them match the spacing on this. I'm not sure what kind of relay this is or this was for, but it certainly doesn't match any of the ones that I've seen so far. I believe I have found a resolution. It's going to be interesting, but I think it's going to work. Here's the hopeful resolution to the relay problem. This is not the 6CB that I've been working on. This is a TFM-6C that I found online for a great deal. The previous owner of this recapped it, or had it recapped, and ever since then it has not been working. So this is a big win. Not only will I be able to use this unit as a donor unit for the relay, which is an exact copy, of course I'll remove it and I'll clean the contacts properly this time without removing that precious surface material. But the work has pretty much already been done for me. It looks like they did a decent job on the recap. They also used good quality caps, so really all I need to do is install this relay or attempt to find a suitable replacement in the future, and then identify what's wrong with the unit as well. It should be something simple since it occurred during the recap. Alright, here are the 2 relays. You can see the one that I cleaned is on the right. All of that surface material has been removed from the contacts. The one on the left is the one I just pulled out of the 6C unit. And you can see it's got some oxidation. It's not terrible. It's not as bad as the other one was, but there's some decent oxidation on there that should be removed if possible. I'm going to use the first method I think that was suggested, which is just actually a pencil eraser and some contact cleaner. I think that'll be the least invasive way to try and clean this. If that doesn't work, I'll move on to another method. I didn't have much success using the eraser. I think it might have worked, except I wasn't able to put enough downward force to clean the contact. without risking bending the pins that they're attached to. And so I tried the next suggestion that was in the comments, and that seemed to work really well. I just used a standard piece of printer paper. I soaked it pretty good in the contact cleaner, and that way I was able to hold it on either end of the contact and rub it with quite a bit of force on either contact, as well as rubbing it on the internal, the fixed contacts as well. And that seemed to clean it pretty well. You can see that the contacts are fairly clean, but the surface material has not been removed like it was on the first one. So that worked really well. I'm going to reinstall this. Everything is finally reinstalled, and I have the unit plugged in, although I don't have any input connected. I'm ready to turn it on. And we heard the relay engage. The power LED is on, so this is a good start. I'm going to hook up some audio now. Actually, before I apply an audio signal, I want to adjust the idle current according to the service manual procedure. And so the first resistor to check across is R824. I have my multimeter hooked up now. I just turned the unit on. I'm going to let that voltage stabilize. Alright, the unit has been on for a while now, and the voltage is starting to settle down. We're at about 8.6 millivolts, and that's pretty high. The spec is 5 plus or minus 1 millivolts. So I'm going to see if I can adjust that down at TVR801 right here. Pretty touchy. There we go, we're at about 5. We're well in spec now. I'm going to move on to the next checkpoint, and we'll come back and check this later. Here's the second checkpoint. This is R924. This is the other side, or the other channel. And you can see we're well out of spec on this one. We should be again at 5 millivolts plus or minus 1 millivolt. The unit's been on for a few minutes, and the voltage hasn't quite settled down yet, but we're trending in the wrong direction. So I'm going to start adjusting this now. This is TVR901. Wow, that is so touchy. Okay, so it's down into spec now. I suspect it's going to trend up a little bit as well as the unit warms up. So I'm going to turn the unit off, and we'll check both test points again, R824 and R924. Alright, the unit's been on for 2 or 3 minutes now, and the voltage is starting to settle down. I don't think it's going to stop here, but it's really slowing down, so I think we're going to end up right in the middle of the spec there, really close to 5 millivolts on this channel. Let's go ahead and check the final channel one more time at R924. Alright, the other channel has stabilized at about 4.8 millivolts, well within the spec. So I think we're good on idle current. Now I'm ready to hook up an audio signal and test. Alright, time to turn it on, test, and make sure that our original failure mode is gone. Alright, so the relay engaged. Both channels are on, and they sound really good. I'm going to let this run for a while to make sure that we're running cool. Both sides of the heatsink are okay, and we have no further issues down the road. Alright, it's been running for about 30 minutes now. It still sounds great. Both heat sinks are ice cold. So this one is all done. Thanks for watching.